Hello. Today I want to talk about an insane feature of equation Lego that makes it really different from the normal way of doing math. And that's the fact that direction is kind of an illusion, right? We know already that we can wire things in whatever direction we want, right? If I have plus this way, I could write it that way, and I could put things around. That doesn't change what we're doing, as long as we're sure in which, do not mistake which one is which. We say, okay, well, if something arrives here and it gets added to the other thing, and then we're fine. And what this means is that by just having addition, I also have subtraction. And it's kind of crazy. So imagine I wanted to say, oh, okay, let's have the four operations. So we have plus. Let's define a minus thing that does what you expect, right? So that's A minus B equals C. But this is equivalent to A equals B plus C. And we know how to do that one, because we can just say, well, A, and depending on how we do it, I'm going to do it like this. A equals B plus C. We know how to do it. And if we wanted to have the same shape, we can just say, oh yeah, here's B, here's B. Here we go. That's subtraction for you. It was there hidden all along in addition. And this is something really different from like normal math. Just doesn't do things like that. You can't just make subtraction happen out of nowhere. And we can do the same for multiplication, right? And division, right? So if I define multiplication here, if I decide that I add a new basic brick to my Lego that does multiplication, then this brick here, and note that I like to go from left to right just because I feel it's natural, but it doesn't need to be. Actually, let's not do that. Let's do that just to be clear that direction doesn't matter. So this is BC equals A, and that's almost C equals A over B, right? So it's not quite. So the difference with subtraction is that we need to care about zero here. So let's say that B is not zero, which is a thing we can do. If we copy B and we plug it into the equation different from zero, so this is the different, that's A different from B, and this is zero, this is A equals zero. So this says BC equals A and B indifferent from zero. And now this is actually equivalent to C equals A over B and B different from zero. So this actually does what we know, which is take an A and take a non-zero B and do the division. Here we go. Isn't that magic? It was just hidden there in plain sight. We didn't even know. And we can even go one step further, and that's as far as I'll go today. Wait, this is the one I care about. Let's move this here. That's the one. And let's just do the final one, which is that if this is squaring, right? So you take an A, and then that's like B, that A square gets here, right? So this B equal S square. But if you look at it the other way, that's also A equals plus or minus square root of B. So there's a bit of an ambiguity here because there's two solutions. But if I just say, well, let's also ask that A is bigger than zero, then this equation here is also this one. And so if I wanted to define some kind of square root operator, I could simply define it as this thing, but the other way. So it would be this, this. Here we go. Square roots. They actually were hiding as well. I could just define them from what we had. So There's this whole thing about the four operations, right? This is how we think about the basic math, and we think, oh, four operations, maybe square roots, maybe other roots. But actually, we got them all from those two things. We have, I mean, copying is barely counts. The actual operations we added are addition and multiplication. And from there, we just realized that subtraction and division and roots already existed. And so this is a really cool feature. And this is part of why I love equation Lego so much.